Hi y'all, welcome to part 5 of chapter 8. In this video, we will be talking about thinking, conceptualizing, and reasoning. So, on the first half of this chapter, we talked about language, and now what we're going to do is we're going to talk about thinking and thought. And so, thinking and thought can also be thought of as conceptualizing and reasoning as well. So we're going to kind of cover what is thinking, where does this occur in the brain, and then some other concepts and reasoning definitions and examples as well. So the first thing we want to know are, what is thought? Now we have 3 different types of thought that we're going to talk about. The first one is called propositional thought. So this expresses a statement, such as, I'm hungry, or it's almost time for dinner. So you can see how it contains a proposition. So it's propositional thought. You're stating something. The second type of thought is imaginal thought. And this consists of images that we can see, hear, or feel in our mind. So you can kind of think of it as like purposeful hallucination. So you're thinking of something in your mind. So you're either forming an image or remembering what something sounds like or what something felt like. And so you're mimicking those actual sensations using just your image or your imagination. Sorry. The final type of thought we're going to talk about is metoric thought. So this relates to mental representations of motor movements, such as throwing an object. So when you think about a type of movement, that's a metoric thought. So you can see how it's motoric. So metoric or motoric thought. So these are our 3 different types of thought. So we either just state a fact. When you're imagining something occurring, imagining kind of a memory, that's imaginal thought. And then metoric thought is where you are thinking about a movement. So during a session, then researchers attach 72 electrodes to a Lundemo's scalp to record his brain's electrical activity. So this was just a dude called Lumendo, and he wore this electrode cap to see what his brain did when he was thinking. So what happened was there was a computer that was attached to these electrodes that measured the electrical activity, and what the computer did was it analyzed the patterns and intensity of the brain signals when he thought. And what it showed was that it used the information to control the movement of the cursor of the video screen. So in other words, what was happening was Lumendo was looking at the computer screen at the same time, and he was actually able to change his thinking in order to move the cursor on the video screen based on just his brain electrical activity because of what the computer was doing. So the computer analyzed the patterns and intensity of the brain signals. It showed it then on the computer screen, and Lumendo was able to change his thinking so he could imagine the computer mouse moving left or right, or maybe he was using his motoric thought and thinking of moving his hand as if it was on a mouse to move this cursor on the video screen. And just by using his thoughts, then he was actually able to move the cursor itself and control it. So this is an example of the power of pure thought. So because of the electrodes attached to his scalp, then Tristan Lumendo uses his thoughts to control the movement of a cursor on a video screen. So the various brain regions became active when he moved the cursor in a particular direction. So by moving the cursor left versus right, different parts of the brain were activated. And so this was a really great study to show, again, just the power of thought and how different parts of the brain are involved in different types of thought. Now, there's also different concepts and propositions that you think about. So a proposition is a statement that expresses an idea. So we did just talk about propositional thought. So that's like a statement, right? And this consists of concepts combined in a particular way. Now, a concept is a basic unit of semantic memory, okay? So propositions are made up of concepts, right? And concepts is a single unit of semantic memory. So with concepts being the building blocks of thinking and reasoning, then you can see how they're pretty important. So we have the concept of students, the concept of intelligent people. But a proposition would combine the concepts. So students are intelligent people. So again, you can kind of see how there's a sort of hierarchical structure to thinking, just like there was to language, right? So we're taking individual concepts and combining them to make a full proposition. There's also these things called prototypes, and these are the most elementary method of forming concepts. So they only note similarities. So children's early concepts are based on prototypes. In other words, if a child learns the word truck because it sees a fire truck, every time it sees any kind of truck or anything that looks like a truck, it's going to say truck, even if it's not. Because what looks like a fire truck? Well, some school buses could look like a fire truck. A big semi-truck would look like a truck. Maybe a minivan. To a kid, that could still look like a truck. So the kid is going to take this most elementary method of a concept, this prototype of truck, and he's going to apply it to everything that fits his prototype, even if it's not necessarily true. And that's what you see with a lot of early language in children, is where they kind of learn a word and then they apply it to everything that to them fits that prototype. Now, as we get older, we are able to tell the difference between prototypes, and we're able to note differences between things, not just similarities. So propositions are not psychologically equivalent, even if logically so. So they can influence decisions. So a 60% survival rate sounds pretty good versus a 40% fatal outcome. If you give someone those two numbers, if you give them a 60% survival rate, they'll think, well, that's pretty good. But then at the same time, if you tell them there's a 40% fatality outcome, they're going to think, wow, that's pretty high, that's not very good. When really, these two propositions are saying the same thing. So logically, they're equivalent, but psychologically, we perceive them as different, okay? And that's because of not using these prototypes. So prototypes only note similarities, not differences. So because we're able to tell the difference between 60% and 40%, then we're not perceiving these propositions as being equivalent, even though they are. Now, what about reasoning, right? So reasoning is really where we're taking all of this information and we're drawing a conclusion, right? Well, there's two different types of reasoning. We've got deductive and inductive reasoning. So first, deductive reasoning is where you get a reason from general principles to a conclusion. And so deductive reasoning is very useful in forming hypotheses. So you're taking all the evidence that you have and combining it to form a reason, a conclusion. Whereas inductive reasoning is kind of the opposite. It's where you start with specific facts and then you try to generate a general principle around them. So rather than taking general principles to draw a conclusion, you're taking specific facts to develop a general principle. Okay? So here's an example of deductive reasoning. So we've got a general principle to specify to a specific case. So we've got general principles that are assumed universally true. We then assess to fit the specific instance. And from that, we draw conclusions regarding an individual case. So we're taking the general principle and we're looking to see, does it fit this case? However, in inductive reasoning, it's kind of the opposite, where you collect factual information, you then evaluate the facts, and then you formulate a general principle. Okay? So again, deductive, you start general, and then you see, does it apply to the specific? Whereas with inductive, you start specific, and then form a general. Now, there are some stumbling blocks in reasoning, and the biggest one is distraction. So you can be distracted by irrelevant information. So when you're collecting facts, there's some facts that just won't really be relevant to the conclusion you need to draw. And by failing to focus on just the relevant information, you could hinder your reasoning. Another big stumbling block is belief bias. So this is where you abandon all your logical rules in favor of personal beliefs. So a great example of this would be the anti-vaxxers, right? They're abandoning their logical rules of looking at scientific fact in favor of their personal beliefs, which I personally think is stupid. Don't come at me, please. Also, with belief bias, then they'll confuse factual correctness with logical correctness. So even though something might be factual, it might not fit with their logic. So they'll ignore the facts because of their personal logic. Okay, so that's belief bias. We see that a lot. Another block in successful reasoning would be emotions and framing. And I'm sure you guys have done this before, where when you're very emotional, maybe through a breakup, maybe your favorite character in the book you're reading died, I don't know, you're not thinking right. And so you might make decisions that you wouldn't normally. And that's because of your emotions and framing. And so this refers to the idea that the same information, problem, or opinions can be structured and presented in different ways. So again, the same problem that comes up when, say, say you're sober, you broke up with your boyfriend, right? And he's texting you. If you're sober and just like with your friends, they're gonna be like, no girl, don't respond, and you won't, right? But if you're alone and drunk, eating a bunch of ice cream and wallowing, it's gonna be the exact same information, the same problem, and your same options will be there, but because they're being presented in a different environment, a different frame, you're going to react differently. You're probably gonna text them back, right? So that's an example of how emotions and environmental framing can influence your reasoning, which then your reasoning is also how you make decisions. So I hope all of that made sense, a great introduction to thinking conceptualizing and reasoning.